All right, so now the particular solution is 5 ln x. So you know the general solution will be the particular solution plus a times the first fundamental solution plus b times the second fundamental solution, that's x ln x, plus c times the third fundamental solution, the c times x, ln x whole square. Okay. So, and the initial conditions are y1 equals 1, y prime 1 equals 5, and y double prime 1 equals 0. So 1, 5, and 0. And 5 ln x, ax, bx ln x, cx ln x square. So y is equal to 5 ln x plus ax plus b x ln x plus c x ln x whole square. And y1 was 1, y prime 1 was 5, and y double prime 1 was 0. Okay. So, in the previous problem, if you remember, we took the first and second derivative and then started plugging in. And the reason for that it was, let me show you again. So this is what we were doing. We had y is equal to this. And the reason is that if you had plugged y equals 1, so y equals 1 here, you would have had three constants in that equation, and you had to go on further, because once you got to the second derivative, you got an equation in which there was only one constant. And then you solved for that constant c, and then you went back and so on. So in this particular problem, actually, this original equation is the easiest one to solve, because at first sight it looks that the presence of these ln's is going to complicate the calculation of the constants, but actually it's going to help, because all the conditions are at x equals 1, so y of 1, y prime 1, and y double prime 1, and ln of 1 is 0. So actually you want as many ln's as possible, and that's exactly what's happening in this first equation. So this one is y of x. And when you substitute x equals 1, this becomes 0, ln 1, this becomes 0, because of ln 1, this becomes 0. And so you just get this one, and you right away find a. So actually this is what you will do here. So I copy this. I know y of 1 is 1, so y of 1 will be 5 ln 1 plus a times 1 plus b ln 1 plus c ln 1 whole square. Let's go. And y of 1 is 1. And now all the ln 1s go to 0, and you just get a is equal to 1. Okay. So now we take the derivative, and once you got a equals 1, you can even put it here if you want. Doesn't matter much. So, okay, I'll just replace this with 1. And now it becomes that. And now I take the first derivative. Okay, so I won't copy this. So first derivative, y prime x. So let's take the derivative. So derivative of 5 ln x, remember derivative of ln x is 1 over x, so it'd be 5 over x. Derivative of x is 1. And here we have to use the product rule on the bx ln x. So derivative of bx is b. And you keep the ln x plus, and then you keep the bx. And derivative of ln x is 1 over x, so divided by x. And then plus, so again, derivative of cx is c. And you keep the ln x squared. And then plus, now you keep the cx. And the derivative of ln x squared, you first use the power rule, 2 ln x. And then by chain rule, derivative of ln x is 1 over x. Okay. So now let's simplify it. So y prime x 5 over x plus 1 plus bx ln x. Now bx over x is, the x's cancel out and you just get a b. And c ln x squared. And here also this x cancels out with this x and you get 2c ln x. 2c, this x is cancelled out with this x. And I've written the 2 outside, so I get 2c ln x. All right, so now I substitute 1, because y prime 1 is 5. So y prime 1 would be 5 over 1. 1, and again, now I know that ln 1 is 0, so this term will just go away. And similarly, wherever you have ln, that term will go away. And this will go away because ln 1 is 0. And now I can, and y prime 1 was also given to be 1. And so from here, b will be -5. This one and this one will cancel out, and this 5 will go on the right side to give -5. So b is -5. And lastly, and now once I have b equals -5, I can already substitute the value here. So this would be, or let me do it in the y prime, because that's where, that's from where I will take the second derivative. But okay, it doesn't matter. It's only a tiny thing. So now we take the second derivative of y prime. So second derivative y double prime of x y double prime of x, and that means you take derivative of y prime. So derivative of 5 over x would be negative 5 by x squared. Okay, derivative of 1 is 0. Derivative of b over x is b ln x is b divided by x plus b divided by x. And the derivative of this b is 0. And then here I will use the power rule, plus 2c ln x times 1 over x. And here it's 2 2c divided by x plus 2c divided by x, because 2c is a constant and derivative of ln x is 1 over x. So now I can substitute the, okay, and y double prime is equal to 0. So now I can substitute the values. So, okay, x was also 1, so this would be 1 square, 1 over 1, 2c ln x. Okay, well, we're right now it's y prime x, so y double prime x, and that's not equal to 0 yet. It will be 0 when we substitute x equals to 1. So now that's what we will do in the next step. So y double prime 1. Now these x's become 1s. And now let's substitute b also. B was negative 5. ln 1. And wherever ln 1, we have ln 1, and that's equal to 0. So we can even zero out this term. ln 1s will make the whole term 0. And now that is equal to y double prime 1 was 0. Oh, I think I made a mistake here. Y prime 1 was 5. So this thing was 5. And so that will give me b equals negative 1, not negative 5. And this is negative 1. Okay. So now from here, I see that 2c, this is 2c, this is negative 1, this is negative 5. So 2c is negative 6. Now when it goes to the other side, it will be positive 6. So 2c is equal to 6. And c would be 3. And now we have all the constants. C is 3, B is negative 1. We already had A. So B was negative 1. C is 3. So 5 ln x plus x minus x ln x plus 3x ln x. Plus x minus x ln x. Oh, okay, let's see if remember originally we made a mistake in B. So b is -1. Okay, so this is fine. Yeah, 2c would be 6, c would be 3. So plus 3x ln x whole squared. 5 ln x, not plus c, but plus x. Okay.